So I wasn't given a firm remit about what to say today, so my talk's sort of in two halves, Damnation and Deliverance, which is just so I could get some opeth into the talk. So the damnation part is about the problems, or some of the problems we face teaching statistics and research methods. Oh, sorry. And the deliverance part is some potential solutions, but the bottom line is there are no solutions. So there you go. This is pretty much how I see myself as working in a psychology department. So we have like 600 students coming in every year, all excited to discover themselves and find out about their inner being, and then I come along with my Pied Pipe and teach them statistics, which they don't all hate, but a lot of them hate. So in terms of some of the problems we face, there's sort of a student side to this and a teaching side to this, and I've split it into two, and I really had to shoehorn a few things in to get a decent acronym out of it, but it's a shambles. So on the student side of things, lots of students lack self-efficacy. They feel like they can't do it. There's a huge diversity in student backgrounds and what they come to university with. And obviously they've been through different schooling systems. So there's lots of students are much more advantaged than other students in terms of their maths background. Lots of anxiety, but they're not all anxious, which is a point I'll come back to. And some of them are just not very motivated. You know, like I said, they came to study psychology, not to study statistics. On the teaching side, in psychology, I can't really speak for any other discipline. Well, actually, the boring just applies full stop, probably, to statistics. Yeah, it's quite a dry subject. I think in psychology, often I don't know what the plural syllabus is, but someone can tell me. I think we're stuck in a bit of a historical rut. Like, a lot of people teach what they were taught in the way that they were taught it. And yeah, I think we can modernize how we teach statistics quite a lot. Expertise, often people teaching statistics in psychology are not the people who want to teach statistics, they're just the most recent appointments. Not true at Sussex, we love a bit of stats. And we are perceived as teachers often as soulless, emotionless android cults. At least that's how my deputy head of school describes the methods team at Sussex. That is a direct quote, I think. Anyway, so is any of the student stuff backed up? So this is actually quite old, but a while back I did some work for the HEA, which was just like a big survey, essentially. And these are staff responses to various questions. So these are questions about, is student self-efficacy lower in quantitative methods? Is student anxiety greater? Is there wider variability in student abilities? And basically the big blobs there are showing that lots of HE staff endorse those statements. So they believe students have low self-efficacy, high anxiety, and there's a lot of variance in student sort of backgrounds. And do students have realistic expectations about the amount of stats in their degree? Well, most HE staff are endorsing that they disagree with that statement that students have realistic expectations. So that sort of backs it up. From the student point of view, and the staff point of view, these were a list of barriers to learning stats. So this is having anxiety, lack of confidence, failure to practice, lack of numeracy skills, and both staff and students endorse those items quite highly. So they believe they have, anxiety, lack of confidence is sort of a big thing. The main thing where staff and students disagree is staff see the failure in students to see the relevance of quant methods to psychology. So we all believe they don't see how relevant it is, whereas students did not endorse that at all. So they clearly think they do see the relevance of it. And staff tend to underestimate the effect of the gap between when most students have studied maths at school and when they come into university. So students endorse that item a lot. There's been a big time elapsed since they last did quantitative type stuff. And we tend to forget about that. Do students actually find it difficult? Well, going back to the idea that all students are anxious, they're not, but there's a core of, say, about 40% who do really struggle with the sort of quantity side of things. So they endorse sort of usually or always finding it difficult, and that's a huge chunk of students, but it is worth bearing in mind that there's another chunk of students who don't feel like that. They kind of find it okay. And this, what we find a lot in our sort of quant exams is very bimodal distributions that really sort of reflect this. There's a bunch of students who are kind of fine with it and get really good marks because it's all, a lot of it's quite mathsy, so you can get higher percentages than you can on essays. But there's another sort of lower distribution of students who really, really struggle. And I guess what our goal is to bring those distributions together, or ideally bring the lower distribution up to the upper one. On the teaching side, is stats boring? Well, even a 2-year-old knows it is.
Zach, what do you think of Daddy's book?
What about expertise, staff expertise? This is a study, it wasn't a particularly good study to be honest, but it illustrates the point. So staff and students were given various statements about the p-value, and they were all false, they were all incorrect, but they were asked to endorse any that were correct. And this is basically the percentage of people who endorsed at least one false statement about the p-value. And basically 100% of students had at least one false belief about the p-value, which is not surprising because the people that teach them, 80% of them had a false belief about the p-value. People that don't teach methods, it was about 90% had a false belief, and in a much earlier study of academic psychologists, almost 100% of them had a false belief. So yeah, I don't know what to do with that really. Another more recent study was looking at researchers' understanding of confidence intervals. So basically this was an online app. You were shown this bar and you could slide this bar up and down, and you were asked to slide it and leave it in the position where the overlapping confidence intervals would reflect an exactly 0.05 significant difference between the groups. So basically you needed to put this, the dot in this bar somewhere between these dotted lines. That's like the correct answer. So these are clinical psychologists, behavioral neuroscientists, and medical researchers. The red areas are the people that got this wrong. So basically, most people don't really understand confidence intervals in this study. So arguably, the people teaching are not always don't actually know what they're talking about. Okay, so moving on to the deliverance. What can we do about all of this?
I have no idea what I'm doing, but I know I'm doing it really, really well.
That kind of sums up me and the rest of the talk. I think there's really not very much good research. I think that is the message I would like everyone to take home is not much good research at all. So we don't really know what works, which gives me a vehicle to just talk about myself a lot and massage my own ego for the next 10 minutes. So these are my anecdotal belief system about teaching, which has no scientific validity whatsoever. So here are the things that I've talked about. I thought the student side of things, I should put them in like a really heavy metal font just to emphasize how evil they are. So we've got heterogeneity in backgrounds, motivation, anxiety, self-efficacy. On the teaching side, sometimes we make it too boring maybe, or it just is boring. Plural syllabus that lives in the past, and the fact we are all soulless, personality-less, statsy people. And here are the solutions based on reflection, and more reflection. So the things that I'm going to talk about, which take them all with a massive pinch of salt, is the importance of finding your voice in teaching, how we can better scaffold, statistical methods in particular, and how we can use differentiated learning, which, I don't know, anyway. And some sort of sub-things here. Finding your voice, this involves these sorts of things for me, but I don't necessarily recommend them for everyone. Using engaging examples, having a bit of personal insight. I mean, that can be a dangerous thing. Scaffolding, I'll talk about that, about the GLM. And in terms of differentiated learning, I don't really have a lot to say about it, but I'll talk a bit about signposting material, and I think I end up doing them in reverse order, actually. So differentiated learning, this is something I've done in textbooks for a while, but I've started incorporating it into my teaching materials as well, which is simply sort of flagging the difficulty of material. So in the textbooks, I have a little icon that indicates this is like a level 3 section, this is like a level 2 section. Now obviously signposting stuff can be a dangerous thing to do, because if you signpost something as level 1 easy and your students find it really hard, that's obviously going to have the exact opposite effect of what you want. But I think sometimes it can be useful to flag to a student, I consider this quite tricky stuff, And so, my expectation is that you might also find this tricky, and that's okay, because it is tricky. But like I said, it's you can definitely fall down some potholes, I think, with if you don't get the differentiating right. The other thing I started doing a lot in teaching materials is having sort of optional materials. So trying to say, well, look, in terms of like, if you just want to pass your exams, here's the sections of the interactive handout that you need to do. Sorry, we teach R, so it's all done with like a lot of interactive kind of web-based handouts. Here's the stuff you need to do. If you're like super into this stuff, oh look, there's this other section where you can find out some more, read a bit more, there's some more exercises to do, but basically you're kind of not going to be assessed on that. Surprisingly, some students do those bits. Scaffolding, this is the typical sort of diagram that you see in the back of textbooks, including my own. Well, this is from my textbook, in fact, which is, how do I choose which statistical test to do? And you've got all these sort of a massive decision tree, how many outcome variables have I got? What type are they? Did you take the dog for a walk this morning? Do you prefer tea or coffee? How old are you? And then at the end, it tells you to do a Mann-Whitney test or something. And I think this is a really overly complicated way to teach things, because pretty much like 90% of the statistical models we fit in the social sciences are variations of the general linear model. So again, in books and teaching, I tend to take the approach of teaching everything as a GLM, because you can then scaffold learning around sort of key concepts. So everything we do involves sampling, parameters, intervals, significance testing, and estimation. So you have this sort of spine, this conceptual spine, and everything is built around that. It also makes another acronym, but believe me, you definitely want the big picture of a spine on your slide, not the other thing. So this is kind of like the template that I give to students at basically at the beginning of every lecture. I go through this slide like, well, we've got a scientific question, we're going to have to do some sampling, and related to that is this concept of the standard error, which we've talked to them about. We're always going to visualize our data, so you get like repetition of these processes, and then all the lectures essentially after about week 2 are variations on the GLM. So they know what the linear model is, and then we just start to teach, well, what happens if we've got categorical variables as predictors? What happens if we've got lots of categorical variables as predictors, ANOVA type design, et cetera, et cetera, et cetera. So everything's getting scaffolded around this sort of common idea that we have a single model. All we're changing is the types of variables that go into it. We're always estimating things, whether that's point estimates or interval estimates. Sometimes we're hypothesis testing. But essentially, week upon week, we come back to this central thing of, oh, look, we got a model. All we're really doing is changing the variables. We're still doing estimation. We're still doing hypothesis testing. We're still using standard errors. We're still using confidence intervals. So everything just gets repeated a lot, essentially. Any model you fit has assumptions. In our case, so there's a lecture early on about the assumptions. They are going to apply to every model we fit throughout the term, pretty much. And when the assumptions go wrong, there are robust variants. So again, they're given a sort of toolbox of things that you can always do with a linear model. You can always bootstrap it. You can always use robust standard errors. So rather than having like millions and millions of different tests, they just learn a sort of a coherent conceptual framework for fitting statistical models. Find your voice. I don't think anyone can say this is the way to teach or find your voice. And I always love this example of a few years ago, I was ill and someone had to give my lecture, my stats lecture, at short notice, or fairly short notice. They were also the sort of person who didn't feel the need to look at my slides before they went in, because they thought, yeah, I know how to teach regression, it's fine. And then, when I came back, I was like, oh, how did the lecture go? Goes, oh, yeah, it was great. I spent a lot of time going, oh, yeah, I don't know what that's all about. It's just Andy. Oh, yeah, I don't know what that's about. It's just Andy. I think there was a picture of Robbie Williams, a cartoon of Robbie Williams being something horrible happening to him. Anyway, lots of stuff. So, what fits me doesn't fit everyone else. And, that's fine. Here are some of the things I do. Doesn't mean they're good things to do. And there's no evidence base for any of them. Anyway, personalization. So textbooks, I have for a while. run like little personal stories in them. I don't know whether that helps or not, but it's less boring probably than reading about standard errors. So at least people start each chapter thinking, oh, well, I've got past page 1 and that wasn't too painful. Well, I don't know, maybe my writing is painful, but maybe less painful than equations, who knows. I do a lot of that in lectures as well. Like I say, I guess you've got to be a bit careful about the stories that you tell. Probably don't use me as a barometer, I would say. What's this all about? Oh, yeah. So taking this to sort of some kind of extreme a few years ago, I decided that maybe a good way to teach statistics was through like a narrative, just have like a story with characters, and basically there would be a character who acts as the student, other characters in the book who act as the teachers, and basically this person in the book learns statistics through this adventure that they go on. So I did that in a book, and then I thought, well, why don't I do that in lectures as well? That might be quite fun. Like have I kind of don't recommend this because it takes so long to write the lectures, but it's quite fun to do. So I now have a series of lectures that have a narrative running through those lectures. So the one on bias in models involves helping a young dragonling to stop a knight from killing all the dragons, and basically through a series of statistical problems, he saves the dragon. I've got a clip of that later on. In my sort of Anovery lecture, I give that around Halloween. That's all around zombies, proving that zombies are scarier than werewolves, and has various characters. I actually dress up as a zombie for that lecture. The repeated measures lecture is stopping an invasion of shape-shifting aliens using puppy sniffer dogs, where I get to dress up as a spaceman. It involves a lot of dressing up. My office is like costume party hire. And my Christmas lecture on logistic regression involves helping Santa, obviously, to save Christmas. And I get to dress up as Santa in that one. So here's the Beast of Bias one. This is my lockdown version of it.
Kill all the dragons.
So my son acts as the knight.
Oh dear.
I dress as a wizard
But
in the
dragons
lecture
are nice. Why would you
and
want
interact
to kill
with him
them?
on the screen.
Because they eat all your sheep.
And this is him telling me why he hates dragons and he's going to kill them all. And over the course of the lecture, we show how his data have been biased and that actually dragons are awesome and he needs to not kill them.
Oh dear. Oh, that all sounds.
My
a bit
other son
old-fashioned,
acts as
kidnapping
the dragon.
princesses.
I don't know
I'm
if
sure
he's in
they
this
kidnap
clip, though.
princes as well these days.
Anyway,
you
doesn't
know.
matter. This is from the Christmas lecture.
Christmas song.
This is
Don't
the
you agree,
logistic
boys and
regression
girls?
song.
I thought so. Let's get to it.
Probably don't need all of this, I'm guessing.
Yeah, it's coming to town. Yeah, it's coming to town. Logistic regression is coming to town. You better watch out, you might want to cry. You better beware, I'm telling you why. Logistic regression is coming to town.
Yeah, you get the gist. You can see the rest on YouTube if you want. Does using narratives improve teaching? Here are the studies that have been done. These are sort of theoretical papers just saying, oh yeah, it ought to. So we can discount them as being sort of having much evidence behind them. The point is, there kind of isn't a lot of evidence. So like, I can say, oh yeah, narratives, they're great. But I've got absolutely no evidence that they actually do any good whatsoever. So yeah, yes, it's an innovation. Is it a good innovation? Who knows? Got no idea at all. I mean, it's certainly a lot of fun for me, but not sure it actually helps. I think that's kind of where I want to end, really. So I think my take-home points are, what are my take-home points? There are obstacles. There's not a lot of research on things that tangibly help to overcome those obstacles. But in terms of sort of engagement and stuff, I think so much is about sort of your, I can't think of the word, your, what's the wording clinicians use? The clinician client. Nope, it's gone. Basically, yeah. If you come across as sort of empathetic and Yeah, rapport. I guess that's it. That's not the clinical psychology thing. Anyway, yeah, basically, I think a lot has to do with just getting them to buy into the idea that you are going to help them and be there for them, which is quite difficult with 600 students, it has to be said. But yeah, I'll stop. Thank you very much.